So welcome back, and we are now looking at the questions that we didn't quite finish off last time, and they are at the bottom of page 94. First up, what is this? This is a hyperbola, and the standard form for a hyperbola is k over x. Are we expecting k to be positive or negative in these two quadrants, top left, bottom right? We expect it to be negative. We don't need to worry about that. That will all come out in the wash. This hyperbola has moved. How do we know it's moved? We know it's moved because the asymptotes are not on the axes. It's moved, in fact, 3 to the left and 6 down. All right. How are we going to convey that in our equation? Well, what we're going to do is we are going to add 3 to every x to move it left. And then we're going to subtract 6 at the back to move it down. All right. All hyperbolas with those asymptotes of x equals minus 3 and y equals minus 6 can be written like that. We want the specific one now that passes through the point 3, negative 20 over 3. So we're going to put this point into this equation, right? And this is what it looks like. Negative 20 over 3 is the y value, and that's going to be k over the x value, 3 plus 3 minus 6. Okay, just to emphasize that, this here is the y value, sorry, the x value. All right, and this here is the y value. Okay, now we need to solve for k. It's not too bad actually, because what we're going to do, I think what might be a good idea, well, let's just work out what we've got on the bottom here. We've got negative 20 over 3 equals k over 6 minus 6. Let's get rid of all the fractions by multiplying by 6 throughout. When we multiply by 6, this 6 divides with the 3 to give us 2, so we get negative 40 equals k minus 36. Notice we've multiplied right through by 6 on both sides. Now we're going to add 36 to both sides, and we get k equals minus 4. K equals minus 4. Remember right up front we said, did we expect k to be negative? Yeah. Here's our final answer. Negative 4 over x plus 3 minus 6. Okay? That is our answer for the equation of that hyperbola. Does it make sense? It always makes sense. All right. Now let's take a look at this one. What is this? This is a exponential graph. Y equals a b to the x. That's our standard parent function or vanilla function. This one has moved down. We know it's moved down because the asymptote is minus 3. So it's actually ab to the x minus 3. Now there's two values we need to find. We need to find a and b. Remember with these that it's actually simpler if we put the y-intercept in first. If we substitute this point in first, 0, negative 1. Negative 1 being the y value, 0 being the x value, then b to the 0 is just 1. So we get negative 1 equals a minus 3. Add 3 to both sides, we get a equals 2. Okay? Now, the last thing we got to do is find b. And what we're going to do is we're going to sub in the other point. We're going to sub in this point into what we know so far. We know that y is 5, a is 2, b we don't know yet, x is minus 2, and we've got a minus 3 here. Right. We're going to add 3 to both sides. We're going to get 8. There's 2b to the minus 2. All right. Remember, 2b to the minus 2 is actually 2 over b squared. So 8b squared equals 2. Multiplying both sides by b squared to get rid of the fractions. So divide both sides by 2, we get a quarter. B squared is a quarter. And lastly, square root both sides. And remember that b could be plus or minus a half, but the base is only allowed to be positive. So b is in fact a half. And we're just going to go back up here. We're going to write the answer over here in a box. Okay, this is y equals 2 times a half to the x minus 3. Okay, there's the equation for that function. It's a downhill. Notice the base is less than 1. The graph's going downhill. It's kind of been stretched a bit by the 2, and then it's dropped down by 3. Right, let's have a look at this. Once again, if you haven't tried these questions, pause the video and try them. All right, but this one over here, in order for a parabola, for a quadratic function to have these x-intercepts, it must factorize like this. It must factorize to a into x subtract negative 4, which is x plus 4, and x minus 6. Right, so this time we don't know how much the graph has moved, right, because we're not sure where we haven't been given the turning point. This is a different type, and we need to be able to deal with this type as well, right? We've got the two x-intercepts, and notice that we've changed their signs inside here, because if we had a 0 here, suppose we were finding the x-intercepts, then we would conclude that x is minus 4 or x is 6, right? If we don't change the signs, then we wouldn't get the right results there. Okay, so if 6 is an x-intercept, x minus 6 is a factor. And if negative 4 is an x-intercept, x plus 4 is a factor. Every single parabola with these x-intercepts can be written in this form. Now, we want the specific one that is also going to go through the point 4,8. What do you think we do? Of course, we just take that point and sub it in, remembering that 8 is our y value and 4 is our x value. So we're going to get 4 plus 4, 4 minus 6. Right, so we get 8. This is actually 8 equals negative 2a. So in fact, a is actually, sorry, this is 8 and this is negative 2. Yeah, so a is in fact negative a quarter. Sorry, a is negative 4. If we divide both sides by negative 2, we get negative 4. Right, and now let's take a look. If we write it back into standard form, we're going to get a final answer of negative 4x squared. Over here we're going to get 4x subtract 6x. That's negative 2x. But negative 2 times negative 4, positive 8x. We're going to get a negative 24, right? And that negative 24 is going to be multiplied by negative 4 to give us negative 24 times, I'm just a little bit anxious here. I think I've made a silly mistake. Right, 4 and 4 minus 6, that's negative 2, that's 8. So, sorry, we've actually got, my apologies. Right. What we've actually got over here, we've got 8 times negative 2. We've got negative 16a. Right? And so in fact, a is actually negative a half. And now our final answer is negative a half x squared. Here we're going to get 4x minus 6x. That's negative 2x times negative a half is positive 1x. We're going to get negative 24 times negative a half is positive 12. My apologies, there's the final and correct answer. And we can actually see, just looking at this, that this looks like it is probably around about 12. That's where I realized I'd gone wrong. It just didn't look right. Okay, it's a good idea to look at our answer and just sort of check, does it kind of make sense? Because it always makes sense. This is an exponential graph. Basic form for an exponential graph, a b to the x. This one, however, has been picked up by 3. We know it's been picked up by 3 because the asymptote's at 3. Now, this one's interesting because we haven't been given the y-intercept, right? Let's pop both these points in and see what happens. When we pop this point in, we're going to get 1 equals ab plus 3. Right, that's 1 equals ab to the 1 plus 3. Right, that is using that point, and we get that equation. When we pop the other point in, we are going to get negative 1 equals AB squared. So AB squared, yeah, plus 3. Okay, so that one there comes from using this point over here. Now, how many variables have we got? We've got 2. But okay, because there's 2 equations. Right, so this first equation can simplify if we subtract 3 from both sides. Negative 2 equals AB. And this next one, if we subtract 3 from both sides, we're going to get negative 4 equals AB squared. Now, if we were to divide these 2 equations, all right, so I'm going to take this, I'm going to call this one equation number 1, and I'm going to call this one equation number 2. If we took equation number 2 and we divided by equation number 1, then what we'll get, we get negative 4 divided by negative 2, we get 2. Notice that the A is eliminated and we get B equals 2. Right, and if B equals 2, then we can sub that in and we can solve for A, and we get A equals minus 1. And our final answer for this question is going to be y equals negative 2 to the x plus 3. Okay, right, we've got 2 more to do, right? And this one, I'm not sure that I'm going to bother to do this one right now, because we will do ones of this type once we've done some calculus. Okay, we haven't done this function yet, so let's leave this one out for now. And let's look at this one. This is a log graph, right? It's a log graph, and we told it's of the form ax plus p. This log graph we know has moved. How much has it moved? Well, it's moved 4 to the left. And the reason we know that is because the asymptote is at negative 4. So this graph is of the form log base a x plus 4. Right, now we need to work out what a is. We're going to, as we've done every time, we're going to substitute in a point. We're going to put that point into this equation. Remembering that 1 is the y value, log base a, x is negative 2. So we get negative 2 plus 4, which is actually 2. Right, so what we've got is we've got 1 equals log base a of 2. And we want to find a. Let's take it out of log form into exponential form. So a to the 1 equals 2. Right, so we in fact know that the base is 2, and our final answer is y equals log base a, so base 2, x plus 4. Okay. All right. Now there's two more. There's basically one more page of questions. We are going to pause there, and we're going to ask you to try these questions, and we will look at them next time. This is just this question 37, and then there's one last thing we want to look at next time, just to tie up one more idea before we leave this topic. All right. Thanks, and have a great day.